In the early days of chemistry, we didn't really have a systematic way of naming chemical compounds. For example, baking soda, rubbing alcohol, and milk of magnesia are all common household items. But their common names don't really tell us anything about them chemically. In order to fix this, chemists adopted a system for naming chemical compounds that helps us determine the chemical compositions. To make things easy, we'll start with binary compounds, or compounds composed of only two elements. The methods that we use to name these compounds depend on whether the compound is ionic or covalent. Binary ionic compounds always contain a positive ion or cation and a negative ion, an anion. We use the following rules to name binary ionic compounds. 1. The cation is always named first and the anion second. 2. The cation keeps its elemental name. 3. The anion is named by taking the root of the element name and adding IDE. Let's try a few examples. The compound NaCl consists of sodium and chlorine. From the periodic table, we know that a sodium ion has a +1 charge and a chlorine ion has a -1 charge. Using our rules for naming ionic compounds, we get sodium chloride. Let's try another one. Ki has potassium and iodine. Again, using our periodic table, we can determine that potassium has a +1 charge and iodine has a -1 charge. Thus, potassium iodide. Now let's say that instead of starting with the chemical formula, we are given the name first and want to determine the chemical formula. For example, calcium chloride, we know that this compound has calcium and chlorine. But calcium is an ion that has a charge of +2, and chlorine is an ion that has a charge of -1. We need to cancel these charges out, so we would write the formula as CaCl2, because it would require 2 chlorines to balance the charge of 1 calcium. In the examples that we've worked out, our metals have only had one type of cation. There are, however, situations in chemistry where a metal can have more than one cation, specifically dealing with the transition metals. For example, the compound FeCl2 contains Fe+2, and the compound FeCl3 contains Fe+3. In this situation, we have to specify what the charge is for the cation. The names for the previous compounds are iron 2 chloride and iron 3 chloride. Here we use Roman numerals to indicate the charge of the cation. Now let's talk about binary covalent compounds. These compounds are formed between two nonmetals. They can be slightly more complicated. Our rules for naming binary covalent compounds are: 1. The first element in the formula is named first, using the full element name. 2. The second element is named as if it were an anion. 3. Prefixes are used to denote the numbers of atoms present. 4. The prefix mono is never used for naming the first element. For example, CO is called carbon monoxide, not monocarbon monoxide. In order to name covalent compounds effectively, it's imperative that you memorize the prefix system. The prefix for 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Let's try to name a few covalent compounds. N2O is a compound that contains 2 nitrogen atoms and 1 oxygen atom. Using our prefixes and our rules, we can determine that the systematic name is dinitrogen monoxide. The prefix in nitrogen comes from having 2 of them, And there is only one oxygen, so its prefix is mono. Another example would be NO. Now we have only one nitrogen, but if we pay close attention to our rules, we know not to include the prefix mono for the first element. So we get nitrogen monoxide.